Welcome back, and what we need to relook is what is it we have done with a term like sigma wi xi. What is it that we have done? Let us consider simple two variable w1 x1 plus w2 x2, right. Minus b greater than or equal to 0 is same as w1 x1 plus w2 x2 equal to b, minus b goes there. The variables are x1 and x2, they can even be looked at as a coordinate space. We do not understand w1, w2 weights, but suppose we take a simple numerical example. What is 3x1 plus 4x2 equal to 7? What is this? This could have been written as 3x1 plus 4x2 minus 7 greater than 0, greater than or equal to 0. So, what is this? Simple, we will even graduate this so that it is easy for people to. So, for x1 equal to 0, x2 will be 7 by 4, 7 by 4 is little less than 2. So, this is one point. Similarly, for x2 equal to 0, x1 is 7 by 3, which is little more than 2. This is that line. Of course, the line does not stop here, it goes all the way here. What is this then? This is this region less than or equal to 7, this is greater than 7. So, basically your single perceptron with n weights actually works as a classifier in n dimension space. Therefore, for different values of weights w1 and w2, you could have classifiers like this. So, now let us look at a simple problem where we have this situation. I have one data like this, I have data like this. The task is find classifier that separates all this data from this data. This classifier worked because it separated all data here from all data here. Now, I want something like that. Please note that I cannot find a single classifier which separates. So, what do? I find one classifier, find one more classifier, then find a third classifier. So, this is a line L1, this is a line L2, this is a line L3. So, basically something less than L2, something less than L3, this intersection of all this will separate out all x's from all zeros. So, basically you need 3 lines, 3 linear separate. Basically it solves a very important problem which persisted for about 25 to 30 years. People did not solve this. When they saw that a single layer perceptron could only do linear separation of data. Suppose you have data like this, it can separate. If only they had put 3 layers of perceptron, you could do an arbitrary separation. This 3 layer was critical, because each layer is one straight line. I simply change the weights W1, W2 for layer 1 or line 1, W3, W4 for separator L2, W5, W6 for L3. This will do the job. So, this took 25 to 30 years to move from a single layer to 3 layers. Now, because you could do for 3 layers, people are now done for 200 layers. This is your deep neural network. Deep neural network, what calls deep learning. This only emerged about 20 years back. So, it is probably taken about 50 years to come from 1 layer to understand 2 layer. It took almost 30 years to come to 3 layers from there on, because all this did happen just like that. Lot of thought process, inability to solve more interesting problems with 3 layers, so on and so forth. So, we will study some of these now, just get an idea, some of these. More importantly, the critical part of this. What we know is this: we have an input x1, I can put a weight w1 to this, we have a input x2, we have a weight w2. Of course, in the vector form the input will be x1, x2, the weight in vector form will be w1, w2, right. Produce an output y which is equal to plus 1 whenever w1 x1 plus w2 x2 is greater than equal to 0, equal to minus 1 when w1 x1 plus w2 x2 is less than 0. These models very similar to your Boolean gate type of thing did not help much. Soon saturated with answers, you could not move forward till somebody thought of interconnecting these perceptrons. How did they interconnect? Very interesting way they interconnected. You have a perceptron 1, you have a perceptron 2. You connect the output of perceptron 1 which is y1 to this, connect the output of perceptron 2, output is y2, right, and you want to, so this is having a weight w21, this has a weight w12, that is weight from perceptron 2 to 1. So, here y1 will be plus 1 or minus 1, plus 1 or minus 1 depending on if w12 y2 is greater than 0 and W12 Y2 is less than 0 and output Y2 is plus 1 and minus 1 depending on if W21 Y1 is greater than 0, W21 Y1 is less than 0. This is the first step. The first interesting step. So, you interconnect perceptrons and one perceptron triggers the other, so on, and of course, each could have a bias B1, B2 if you want to make it more general. Each can have its own activation function. Those are more details, we will not get into that. This is interesting because it gives you a complete clarity when we do something better. We now have perceptron 1, we have perceptron 2, we have a perceptron 3. These are not 3 layers, it is connected. W21, W12, this is W32, this is W23, this is W31, this is W13. Output is Y1, this output is Y2, this is Y3. So, it is of the type sigma Wij Yj for all j and I not equal to j. So, Yi is equal to plus 1 if sigma Wij Yj is greater than 0 for all Ij, but j not equal to I, equal to minus 1 if sigma Wij Yj is less than 0 for all Ij not equal to I. This can be extended to thousands of neurons. In fact, it will be even more interesting if this 2D can be extended to 3D. Now, you realize why the this is a tensor. Tensor is a 3D matrix. Now, you know why NVIDIA is producing a tensor processing unit instead of CPUs. That is the reason why if you connect these in 3D, which is approximately a crude brain. This is the reason why your deep nets or general machine learning now dominates. And NVIDIA now makes your GPU, which does this, processes it like this, and a TPU which processes it like this directly. Your CPU was processing it like this, that is all. You had a simple linear array which you could process at the most. To do this takes 10 times more resources. To do this it will take 1000 times. That is the reason why GPU and CPU or GPU and TPU processors now dominate most applications regarding this. Okay, we will come to this now. So, we will move towards multi-layer perceptron now. So, you have x 1, x 2, x, let us just look at 3 inputs x 1, x 2, x 3. They are connected to neuron 1. By a weight W1, W2, W3, it produces an output Y which is equal to -1 if sigma Wi xi I equal to 1 to 3 plus W naught, which is a bias term, is less than or equal to 0 is equal to +1 if this is greater than 0. Why I marked neuro? So, this is the input part, this is the output part. We can call it output layer, input layer, and there is no separation in this. Suppose we do something more on this, like the following. I have input x 1, I have another input x 2, I have another input x 3. I have connected to neuron 1, I have connected this to neuron 2, connected this to neuron 3 in the following way. X 1 is connected to 1 by W 1 1 1, it is so from 1 to 1, this is connected to W 1 2 1, this is W 1 2 2, W 1 3 3, this is connected to W 1 3 1, this is connected to W 1 2 3, this is connected to W 1 2 1. So, all these are connected and these are further connected, let us say to this. This is the output now Y. So, this is the input layer, this is the output layer, this is the hidden layer. This hidden layer is completely masked from input to output, and the weights for this will look as follows. Weights for this will be W 211, W 221, W 231, second layer weights. Okay. So, the first layer hidden layer weights from input to hidden layer will be W111, W112, W113, W121, W122, W123, W131, W132, W133. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 weights, and this will be the weight matrix for layer input to the hidden layer to output layer. The weight matrix will simply be W211, W221, W231. Now just imagine you have n inputs x1 etc. xn, you have n minus 1 hidden layers, then you have an output. Okay. This is the only way you need to work it out, but just getting an idea how it is. The coding part is separate, the representation is slightly different, but intuitively what it means is for every layer you will have weight matrix, right, and as the number of layers increase, complexity and capability both increase, but so is the training burden, etc., etc. That also increases. Okay. So, we just saw what happens when you have one hidden layer. Much more complex stuff it just has to be scaled up. It is not a Greek and Latin problem. Okay. But how does it work? How does multi-layer perceptron work? Weights, that is Wij for all layers, and updating mechanism for weights. Over epochs or iterations. Iterations is not a correct word, epochs is a better word, simply meaning that you train from input to output all over again multiple times. Okay. People are familiar with iterations, epochs are its combinations of iterations. Okay. There is an algorithm it is called back propagation. These two will make it happen. We will see this in the next session, but the summary for this perceptron works not enough. Multi-layer basically interconnected. Perceptrons do better. Now, 3 layers are well understood. Moving to hundreds to 200 layers called deep learning.